Next is number 14. This one is the one we discussed in class. I'm actually going to skip this one on the video and we can talk about it again in class. Number 15. Well, let me make one quick comment about 14. We discussed in class, you graph the inequality constraints. You're going to end up with something like 13 with this region of overlap. The vertices, this is 13, but the vertices on 14, those values, you are going to plug into, well, let's go back to it for a moment. You're going to plug in for C. You do not graph C. When you plug those vertices in, the vertices that you get, this is the graph. Remember we discussed the typo. It should have been 3x minus 2y is greater than or equal to 6. You get these vertices here, 2, 0. Also, you have 4, 3, and 0, 2. 2, 0, 4, 3, 0, 2. You plug these in for x and y. 2 times 2 plus 6 times 0. 2 times 4 plus 6 times 3. And then for x and y here, 2 times 0 plus 6 times 2. That will be 4. 8 and 18 makes 26. 0 and 12 makes 12. Well, what's the biggest number that you see? 26, which means we have a maximum at 26 at the point 43. Which number is the smallest? 4. So we say we have a minimum of 4, and that's at the point 20. So if we were doing maximizing profit, your goal would be to sell, if this was jeans and shirts, 4 pairs of jeans and 3 shirts, you'd get the most profit. If you wanted the least profit, you would only sell 2 pairs of jeans and 0 shirts. You'd make a whopping $4. And that's an example of linear programming. 15. Now we're getting into chapter 4, which was on quadratics. And this is the trick question they like to ask. Does it open up or down? Well, remember that typically our quadratic equation is written like this. Highest exponent with the degree. First, a, the coefficient of x squared, tells you if it opens up or down. And since a is a positive 3, even though it's at the end, it opens up. They're trying to trick you here by putting the c value first, which is negative, hoping you will say it opens down. All right, moving on to number 16. Factor. So, difference of squares. Please refer to your half sheet on factoring. There is no GCF. We simply say 2 terms, the square root of each. The square root of 16x squared is 4x. The square root of 25 is 5. Stick one with a plus and one with a minus. Now, how do you know if you're right? Go back and FOIL. Check and see if you are foiling it correctly. And then you know if you're right or not. And then you will see why there's no BX, because the outer is negative 20, inner is positive 20, making 0 x's. 17. Solve by factoring. Again, please refer to your half sheet on factoring. Factor the GCF out of 4 first. 4 is just hanging out for a moment. Let's factor inside the parentheses. Because it's a 1x squared, I know that's going to go here. I can simply ask what multiplies to make negative 4 and adds to make a negative 3. Well, not 2 and 2. However, 4 and 1, negative 4, positive 1, will give me what I need. And if you remember my magic trick, we talked about if you're multiplying numbers together and the answer is 0, we know one of our numbers had to be 0. So either he was 0, he was 0, or he was 0. Well, certainly 4 is not 0, which means it's either x minus 4 or x plus 1 that was the 0 number. And when you find x, you get 4 or negative 1. And there's your solutions. Always check them back in the original, and that's how you know before you even turn it in if you did it right or not. So we're going to break here and pick back up in the next clip.